Okay, so let's get started. So today we're going to there's a bunch of odds and ends that we haven't finished covering, and so we're just going to basically present a lot of small results. Okay, so small things. Okay. I think let's start off actually with what we were doing at the end last time, which was finding solutions of differential equations of differential equations using power series. Now, one thing that I think was a little bit confusing was that I think can be clarified with something called the identity theorem. The identity theorem, and it basically says that if you have two power series, that equal each other, say on R, although you don't need it to be on all of R. Okay, but anyway, if you have two power series that equal each other, in fact, on some small interval, negative epsilon, positive epsilon, say. In fact, it could be on any small interval. So let's say that they, anyway, we'll just say it like this. Suppose you have two power series, and these power series converge. Say both of these guys converge in some negative R. And let's say that they are equal there. Okay. Say that are equal in negative R. Okay. Then all the coefficients have to be the same. A sub n equals v sub n for all n. If they agree on some small, if they agree in that interval, then they have to be completely identical. Okay. So yesterday, you remember we did some stuff and we ended up with like some power series equals 0, right? And then we said, okay, that means that the coefficients have to be 0 everywhere, right? That's because of this. You think of this as, here's a power series on the left, here's a power series on the right. Okay, this power series on the right is 0xn from n equals 0 to infinity. Power series on the left is a sub n x to the n from 0 to infinity. And they're equal to each other, and so the a sub n's all the coefficients must be equal, right? A sub 0 must be 0, a sub 1 must be 0, a sub 2 must be 0, a sub 3 must be 0, etc., etc. Okay, so that follows from this identity theorem. Okay, so at the very end of class, we were doing this one example. I had given this exercise. And the exercise was, you wanted to solve this. Y prime minus y equals x. Y times 0 equals 1. Okay, right. And we did the game, right? And we ended up with summation n from 0 to infinity, n plus 1, a sub n plus 1, minus a sub n, x to the n equals x. Right? Okay. So at this point, just to let me go over it again because it was kind of rushed. At this point, what happens is that you say, okay, we have a power series on the left and we have a power series on the right. This power series is 0 plus 1x, right? This guy on the right is 0 plus 1x plus 0x squared plus dot dot dot, right? So the coefficient of x is 1. The coefficient of everybody else is 0, right? Okay. So what you know is that when n equals 0, you get a1 minus a0 equals 0. When n equals 1, we have when n equals 1, we get 2a2 minus a1 is equal to 1. Right? Right? I hope. Right? 2a2 minus a1 is equal to 1. Right? When n equals 2, we get 3a3 minus a2 is equal to 0. When n equals 4, when n equals 3, we get 4a4 minus a3 equals 0, and so on and so forth. Okay, so this one is from here, and all the zeros are from the zeros. So so that gives us that a1 equals a0, a2, well, yeah, a2 is what? 1 plus a1 over 2. Right. A3 is a2 over 3. A4 is a3 over 4, and so on and so forth. Okay. And then you notice that since y at times 0 is 1, that tells you that a0 is 1. Right? Is that clear? Because y0 is 1, right? Y is a0 plus a1x plus a2x squared plus da da da, right? So y times 0 is a0, which is 1. So we're just going over the example that we finished with last time. Okay. Okay. So a0 is 1, so we get a1 and a0 are 1, a2 is 1, a3 is 1 over 3, a4 is 1 over 3 times 4, a5 is 1 over 3 times 4 times 5, blah, 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 blah. Right? And so just what we did last time, we see that the power series for y is actually 1 plus x squared plus summation 2 over n factorial x to the n from n equals 3 to infinity. Okay. Does this look like something? What is this? What is this thinking? What is this? It looks sort of like e to the x, except we're starting from 3, right? If only we had, so this is basically like 2e to the x, right? We have a 2 here, so it's 2 times e to the x, but we're missing the first 3 terms, right? We're missing the 0 term, we're missing the 1 term, and we're missing the n equals 2 term. Right? If we had these terms in here, this would actually be e to the x, right? But we're missing them. Is that clear? Is that clear? Remember, right? So e to the x, right? E to the x. Whoops. e to the x is summation x to the n over n factorial from n equals 0 to infinity, right? Here, our sum, I'm going to pull the 2 out just to make it cleaner. We have x to the n over n factorial from 3 to infinity. We're missing the 0 term, the 1 term, and the 2 term. Okay, so this thing here, right, so what is this? This is e to the x, but it's missing the first 3 terms. Okay. So this is actually 1 plus x squared, plus twice that, right? 1 minus 2 times 1 minus x minus x. And so what do you get? That's actually 2 e to the x. We have minus 2, so minus 1, minus 2x plus an x, so minus an x, minus x squared and plus x squared. Okay. So just arithmetic gives you this last thing. And so you see that the solution is actually something pretty recognizable. 2 e to the x minus 1. Okay. Okay. Let's do one more. Let's just do one more to get the idea down. Another exercise. So y prime minus 2xy equals 0, and y at 0 is 1. Okay. So this one again is a little bit different. You have to shift it another way. Okay. So this one is just a tiny bit trickier than the last one. Okay. But I think you can do it. Okay. So take say 3 or 4 minutes and see if you can do it. Okay, shall we do it? Okay, so let's do it. Yeah, please close your computers. Okay, so y, you say, okay, let y be a power series, right? Then y prime, from n equals 0 to infinity. Y prime is going to be summation from n equals 1 to infinity, and a sub n x to the n minus 1. Right? And so plugging this in, what do you get? You get summation a sub n x to the n from n equals 0 to infinity minus 2x times y, right? 2x, oops, that's not right. You get y prime, sorry, and from 1 to infinity, and a sub n x to the n minus 1 minus 2x times y, right? So we get 2 a sub n x to the n plus 1 from n equals 0 to infinity equals 0, and y times 0 is equal to 1. Okay. Okay. So what do you do? What do you do next? Say it again. A0 equal to what? Well, let's figure out, let's try to put this together first, right? Let's put it together first. This is going from 1 to infinity, this is going from 0 to infinity. You want to make this go from 0? Okay, you can do either way. You can make this one go from 0, or you can make this one go from 1, whatever. Okay, so let's make this one go from 0 to infinity, right? So you get n plus 1, a sub n plus 1, x to the n. Combine it with this guy, minus 2 a sub n, x to the n plus 1 equals 0, right? In other words, n plus 1, a sub n plus 1 minus 2 a sub n, x, wait a second. Okay, so that's a little bit, okay, that's not what I want to do, in fact, right? You see, it doesn't quite work out for us. What I want to do is make the indices start at the same time. Okay, so look, yeah, so there's a little bit of trouble here, right? Right, just now, if you do it that way, right, look what happens. If we go from here, a sub n plus 1, x to the n, minus 2 a sub n, x to the n plus 1, blah, equals 0. Okay. But then you can't really say that, right? You want to have the coefficients, equal, you want to set the coefficients all equal to 0. But it's not completely clear what the coefficient is. Okay. So, because, right, this is x to the n, and this is x to the n plus 1. Yeah, one.
You want to use the y prime minus y, but you see from the left, you write down x to n plus 1. Is that x to n?
Here?
No, the about.
Here?
The about function.
This one?
Yeah, you see the one on the right.
2 a sub n. That's right, right? Because remember, we've got y times 2x, right? 2x, so the thing goes up by 1 here. Okay. Okay. So for this one, actually, you need to do a little bit more work. You say, okay, look. Okay, everybody look for a second, please. So this series starts at x0, right? This series starts at x to the 1, right? X to the 1. So I'd like them both to start at x to the 1. Okay, so what I'm going to do is I'm going to take out the first term here. Okay, so I'm going to take the n equals 0, n equals 1 term, right? So this is going to be summation n from 2 to infinity, n a n x to the n minus 1, and the n equals 1 term, a1 x to the 0. Okay? You see what I did? I just broke this up into two pieces. The first piece and everybody else. N equals 1 and n equals 2 to infinity. Okay? And then I have this guy here, n from 0 to infinity, 2 a sub n, x to the n plus 1. Okay. Why did I do that? So that these guys would run over the same powers. Right? It starts at x to the 1. This guy also starts at x to the 1. Okay. Everybody see that? Right. Okay, so now let's combine them together by dropping the index by 2 here. Okay, let's drop the index by 2. Okay. So we get a1 plus summation n equals 0 to infinity, n plus 2, a sub n plus 2, x to the n plus 1, minus 2 a sub n, x to the n plus 1. Okay. Now you see that's a lot easier, that's a lot better, right? We have a1 plus summation n equals 0 to infinity, n plus 2, a sub n plus 2, minus 2 a sub n, times x to the n plus 1. Okay. Okay. Everyone following? Anybody lost? This is the last day. I don't want anybody to be lost. Okay. So what do we have here? We can again play this game. This fact here again implies that a0 is 1. So we know that a0 is 1. And we do the same comparison game, right? What's the coefficient of, what's the constant coefficient here? All the coefficients are 0, right? So what does it tell me? A1 is 0, right? A1 is 0, right? And then what we have is when n equals 0, we get 2 a sub 2 minus 2 a 0 equals 0. Right? When n equals 1, we get 3 a sub 3 minus 2 a 1 equals 0. We get when n equals 0, n equals 1, n equals 2, n equals 3, etc., etc. So when n equals 2, we get 4 a sub 4 minus 2a 2 equals 0. We get 5 a sub 5 minus 2 a sub 3 equals 0, and so on and so forth. Six a sub 6 minus 2 a sub 4 equals 0. Okay. So you have this puzzle, and what do you notice about the odd terms? What do you notice about the odd terms? 1 point, a bonus point on the exam tomorrow for the person who figures it out.
All zero.
They're all 0. 1 volt gets it. They're all 0, right? Because A3, right? A3 is 2/3 A1, right? A5 is 2/5 A3, but A3 is 2/3 A1, right? And remember what A1 is. A1 is 0, right? So A3 is 0, A5 is 0, A7 is 0. They're all 0. Okay, so all the odd terms are 0. Yes? So the odd terms, odd numbered, right? Not the even terms. We'll get to the even terms in a second. I don't know how to say odd and even in Chinese. How do you say odd and even? 基数 and 偶数 偶数 which is which? 基数是哪一个？ Okay, thank you. O is like a pair, right? A pair. Okay. Okay. Now, what about the even guys? What about the even guys? Well, what you see is that, right, 2A2 minus 2A0 is 0. So A2 equals A0, right? 4A4 minus 2A2 is 0. So you see that A4 is what? 1/2 A2. Right? A4 is 1/2 A2. 6A6 minus 2A2 is 0. So A6 is going to be, whoops, what am I doing? Should be A4, right? A6 is 1/3 A4, which is 1/3 times 1/2 A2, right? A8 minus 2A6 equals 0. So that tells me that A8 is 1/4 times 1/3 times 1/2 A2, right? Et cetera, et cetera. Okay. So, in other words, A sub 2n is 1/n factorial times A sub 2. A sub 2n is 1/n factorial A sub 2. Or A0. A2 is A0. Yeah, one B.
How we get A0 equal 1 from Y0?
So y is A0 plus A1x plus A2x squared plus da 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 da. So y at time 0 is A0, right? Y at time 0 is A0, and we're given that Y0 is 1, so that tells me that A0 must be 1. Okay? Okay? So what you see is that the power series, right? So Y is this power series, but it's a power series with only even terms. All the odd terms are 0. Right? All the odd terms are 0, and so what we have is right, a 2n x to the 2n from n equals 0 to infinity. Right? Only the even terms exist. Okay, only the even terms exist, right? So a sub 2n, x to the 2n, right? So we get a sum from n equals 0 to infinity of a0 times x to the 2n over n factorial. A0 was 1, sorry. Why am I including it? A0 was 1. Right? So y is x to the 2n over n factorial. Okay, now what is that? Does anyone recognize that? What is that? X to the 2n over n factorial. E to the 2x? Not quite. Not quite. E to the 2x would be 2x to the n over n factorial. Right. That would be e to the 2x. So you'd have 2 to the n, x to the n over n factorial. Right? Because e to the x is summation x to the n over n factorial. What's e to the x squared, right? This is e to the x squared. Right? Because x to the 2n is the same thing as x squared to the n. So you recognize it. This guy, the answer is e to the x squared. Okay, any questions about this? Any questions about this? This is, yeah, 20.
I have a equals e to the x squared without me on the above without x squared.
Yeah, right, so this x to the 2n is the same thing as x squared to the n. So let me rewrite this as x squared to the n. Right, x squared to the n. And remember, we have seen a few times before that e to the something is summation something to the n over n factorial from n equals 0 to infinity. Right? So what is this? This is x squared to the n over n factorial. So it's e to the x squared. You don't see it? Right? E to the something is summation something to the n over n factorial. So here it is, something to the n over n factorial. Right? So this is e to that something. Right? Right? If I said, what is e to the I don't know, what is e to the x cubed? What is e to the x cubed? What's the power series for e to the x cubed? Well, you would say, well, I'm just going to put in x cubed into the power series for e. Right? What is e to the x to the 4? What is e to the sine x? What's the power series for e to the sine x? Well, this is not really a power series. Actually, it's not a power series. But you could evaluate e to the sine x by putting in sine x. So here you have, what's e to the x squared? E to the x squared is x squared to the n over n factorial summation. Is that clear? Is it really clear or no? Okay, I wasn't gonna play this game until later, but let's play it. So the game is, what is the series? Okay, so here's a bunch of things, and I want you to tell me what series it is. Oops, oops, oops. Okay. Let me put one more up, but go ahead and start trying to guess. See if you recognize the series, right? Here are a bunch of series. What are these things? These are actually things you should be able to recognize.